Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. This week's episode was hard to bring into focus because every time I thought I knew the storyline up, something new came out demanding to be included. In the end, some of that stuff is just going to have to wait. For instance, news came out earlier today, March 20th, that the Dark Energy Survey instrument had found evidence that dark energy varies over time, which no one thought could or would be the case. This isn't a for certain thing, and I'll be covering this in depth next week. There was also news coming out of the Lunar and Planetary Science Conference and the lack of NASA budget, future mission plans, and more, and not all of that made it into this episode. What did make it in? We have a lot of Mars and Venus science from LPSC, and a deep dive into the science successes and failures of the recent CLPS missions to the moon. We also do a roundup of the latest news from the launch pad, and even news of a new ancient crater found here on Earth. All this and more is coming to you right here, right now, on EVSN, a product of CosmoQuest X, and supported through our Patreon. During the week of March 10th, the planetary science community gathered in the Woodlands, Texas, a suburb of Houston, and also in Zoom, as we watched dozens and dozens of presentations on everything from tomorrow's planned missions to today's latest research results. I was one of the people on Zoom, so I was missing the between sessions gossip, but I can bring you the science. And since the panels are all still up for attendees to rewatch to their heart's delight, this may be a multi-week review of what all I have learned and will be learning. My personal starting point was Mars. Special sessions focused on Perseverance over in Jezero Crater, and there was also talk of Curiosity in Gale Crater. Percy, originally called Mars 2020, launched on July 30th, 2020, and arrived on Mars in February 2021. A pandemic baby, this mission has over and over proven that researchers can and will work from anywhere via any means necessary to get their research done. This mission was meant to be part one of two, as it roves through the river delta that sprawls across Jezero Crater. Perseverance is collecting rock and mineral samples in 43 different sample tubes. 10 samples have been cached along the way. 3 samples will be kept on the rover in perpetuity as references, and ideally, 30 samples will be returned to Earth. At least in theory. The Mars Sample Return mission is not slated to launch this decade, and in all likelihood, we can't expect samples to be returned any earlier than the mid-2030s. For those of you now thinking, but SpaceX plans to launch humans to Mars by 2030, I'd like to point out that Starship hasn't met any of the required milestones for going to the moon by 2030. And it was supposed to have made its first landing on the moon 2 years ago. Based on past performance and lack of needed technology to maintain humans on a multi-year mission, experts don't anticipate humans leaving for Mars this decade, and the next decade is looking to be a challenge as well. As much as it's intriguing to imagine humans walking up to Percy to collect his samples for return to Earth, that isn't something likely to happen anytime soon. And researchers hold out hope for a robotic mission making the round trip as a test of the technology that will be required to bring humans back from Mars. With Percy's mission still going strong in No hurry to fill up sample tubes in anticipation of a soon-to-arrive sample return mission. Researchers are now very carefully selecting what samples are sample tube worthy. Helping with that selection process is the Sherlock instrument, which can abrade rocks to reveal the surface and then do multispectral measurements to understand what the rocks are made of. Working in partnership with the Watson instrument, a wide-angle topographic sensor, researchers are able to look at the context of different rocks and then zoom in to see minerals in detail with Sherlock. While not equipped to identify life, they can identify organic compounds, the stuff necessary for life as we know it. And they are finding lots of organics to tantalize folks like me with the hope that someday we'll find fossilized life, however tiny, in the sedimentary layers of Mars' surface. But it hasn't all been going entirely smoothly. Sherlock's motor had a very bad moment last summer when it got jammed with the dust cover closed. Team researchers were able to get the dust cover open, but they lost their ability to autofocus along the way. Now, to focus Sherlock, they actually move the entire camera back and forth until they are most in focus. And the way they figure out if things are in focus is super clever. The way modern image compression works, images are larger the more detail they contain. Since unfocused images will be a fairly monotone smear and in-focus images will be much more detailed. They place the camera about 4 centimeters away from what they are imaging because that's about where focus should be, and then move the camera in and out ever so slightly to figure out where they see the maximum file size. This is computationally simple, and I really love the simplicity of this solution. Looking ahead, NASA did an entire special session on the future of Mars exploration. As a reminder for those of you who track these things, there are low-energy launch windows to Mars in late 2026 and over Christmas and New Year's in 2028 and 2029. The U.S. doesn't have specific missions planned for either of those launch windows, but we are collaborating with ESA on the Rosalind Franklin lander, which will launch at the end of this decade, and the private U.S. company Relativity Space will be launching a mission at the end of the next year. Our next big Mars effort will be the as yet unscheduled and unselected Mars sample return mission. The other big topic of discussion at LPSC seemed to be Venus. I say seemed because I'm sure the actual big topic of discussion was proposed budget cuts, which could be as much as 50%. But there was no definitive information on budget cuts, so that is more a big topic for gossip than for actual fact-based discussion. So let's look at Venus. The most recent missions to Venus were Japan's Venus Climate Orbiter, which studied the Venusian cloud cover from 2015 to 2024, and ESA's Venus Express, which also studied Venus's atmosphere and orbited from 2006 to 2015. Together, these two missions provided nearly 20 years of continual atmospheric observations, which is cool and all, or at least super hot and acidic. But in the decades since these two missions were designed and launched, researchers have realized that Venus may still have active volcanoes, and it may once have had habitable conditions, including oceans. Researchers are deeply interested in understanding if Venus, Earth, and Mars may all have been briefly capable of supporting cellular life, microbes, and bacteria at the same point in our solar system's history. And let's face it, volcanoes, especially active volcanoes, are just kind of awesome. And everyone is excited that Venus might still be geologically active. This research is based on radar data from the 1990s that was obtained by Magellan, and new radar instruments are planned for future Venus explorers, such as NASA's planned Veritas mission. Researchers are also learning how to image Venus's surface using the Parker Solar Probe, which periodically does flybys of Venus. And the future Da Vinci mission is being designed with a descent probe to do further imaging. Unlike Earth, it doesn't appear that Venus has crustal plates that move across its surface, defining volcanically active regions associated with plate boundaries, like we see with Earth's ring of fire. Instead, Venus has other volcanic drivers that new data is really needed to understand. Several researchers pointed out that we are at least 10 years away from getting data back from new missions planned for Venus. On the one hand, that means there will be an amazing 30 years or so between Magellan's radar data from the 90s and any new data, and we will potentially be able to see changes in the surface caused by volcanic activity. On the other hand, researchers currently planning Venus missions are pretty senior, and more than a few will qualify for Social Security before we get that data a decade from now. This long stretch between Da Vinci and Veritas getting selected in 2021 and their potential arrival sometime in the 2030s means there will be researchers who spent a significant portion of their career proposing these missions in the 2010s, dreaming of launch and waiting for data. It was while watching these presentations that I became acutely aware that I could be one of those people past Social Security age holding on to my job so I can report on those future Venus discoveries. That was a bit of a horrifying realization. Although, to be fair, who among Gen X will really be able to fully retire? At least I know I should have some pretty amazing news to report when my hair is truly gray and probably still dyed magenta. Well, I spent a lot of LPSC dreaming of Venus and Mars while learning about new results. Many others were actively preparing for near-future exploration of the Moon. Central to the human return to the Moon is NASA's collaboration with commercial partners. After the break, we'll be back to look at the most recent lunar landings and plans for future missions. Stay tuned. Space exploration is at a weird point in its development. Some tasks, like launching small and medium-sized satellites to low Earth orbit, are now as routine as overnight shipping. At the same time, landing things on the Moon somehow seems to be harder than it was in the 1960s, as mission after mission doesn't quite nail their landing. In this kind of a moment in time, you might expect launches to be just another contracted activity while significant research and development money is invested by the federal government into the innovations necessary to make lunar landings also look easy. At least that's what I would expect. But that isn't exactly what's happening. In 2018, NASA shifted to offering contracts to commercial companies to deliver instruments and things as advanced as the Viper rover to the lunar surface. These contracts would only cover costs associated with the NASA instruments and are not meant to fund innovation so much as to cover, well, inspiration as they inspire companies to make the lunar surface the next frontier in capitalism. That may sound a bit harsh, but I'm not sure how else to put it. These are commercial companies that have to come up with their own ways to make a profit going to the Moon. And in this environment where NASA doesn't pick up the entire bill, we're seeing less success than has been present in past exploration, where corporate costs got covered by NASA's budget. Those past full cost plus fee contracts meant that when engineers realized that building Mars Curiosity was a whole lot harder than anticipated, they had the funding they needed to figure out how to make everything work. Now it is venture capitalists and other corporate funders who are watching the bottom line and demanding exploration on a budget. In our last episode, I recorded a coda that covered the failures of Intuitive Machines' second lander and Starship's 8th launch. These are both commercial endeavors, and both companies seem to be having issues getting everything to work as required. With Intuitive Machines' second landing attempt, we saw the lander fall over for the second time. Like with its first attempt, it had a failed altimeter and wasn't entirely sure of where it was relative to the lunar surface. It's reported the mission landed, fell over, kept firing its engines, skittered on its side across the moon, and ultimately ended up in the bottom of a dark crater covered in lunar dust, like a baseball player that slid past home plate on a dusty summer day. While all the experiments and the rover on board called home that they were okay, Intuitive Machines was unable to deploy them to the lunar surface. Within a day, the mission was out of power and dead in a cold, dark shadow. What was on board? The tiny Japanese Diamond Company's Yoki rover, NASA's Prime 1 with the much-awaited Trident drill, and a variety of smaller instruments and experiments from universities like MIT, companies like Nokia Bell Labs and Columbia Outerwear, and more. All dead, with very little data collected. Instead of exploration of a permanently shadowed crater, we got an image of the Earth rising up between the lander's legs. So far, we've seen Astrobotics Peregrine fail in orbit, Intuitive Machines' 2 different landers fall over, the first iSpace lander somersault, Israel's Bereshit crash, and many other nations' governmental landers also have experienced difficulties. The bright points of success are China's Chang'e program, India's Chandrayaan program, and one little commercial lander, Firefly Aerospace's Blue Ghost. Did you know that a blue ghost is a kind of firefly? I learned that by accident, and it brings me joy, as this mission has brought so many of us joy. I was actually able to see Blue Ghost in the second iSpace mission launch while I was in Florida earlier this year. The iSpace lander will be landing in a few weeks, and if it also succeeds, I would like to argue that I need to attend all lunar launches as a good luck charm. All joking aside, Blue Ghost just worked, and its landing cameras allowed us to see amazing dust interactions as the lander fired its engines to slow its descent. It landed right where they planned, and the image they have of their own shadow captures their wonderfully upright orientation. Blue Ghost didn't carry any rovers, but it did have 10 different NASA payloads that all completed their mission goals, including drilling into the lunar surface and imaging a solar eclipse with the Earth blocking out the sun. Other mission highlights include acquisition of signal from Earth's global navigation satellite system, a brief study of how the Earth's magnetosphere interacts with the solar wind, measurements of the moon's magnetic field, and my favorite experiment, an electronics package designed to remove lunar dust using an electromagnetic field. On March 16th, after 14 days of science, the moon's rotation carried the lander into shadow. While it is possible it will wake up when the sun rises, that isn't expected. Firefly Aerospace already has plans for their second lunar mission sometime in 2026. Blue Ghost 2 will be landing on the far side of the moon. Here's to hoping that lander is just as successful. And as for iSpace's lander, Hakuta R Mission 2, they are looking to try and land no earlier than June 6th. And when that happens, we'll bring you news right here on EVSN. Before we go to break, I want to call to your attention a breaking story that has me and colleagues concerned for the future of international collaborations in space science. It has come out that a French researcher on their way to the Lunar and Planetary Sciences Conference was detained while entering the U.S., and due to digital communications on their phone that were negative about U.S. policies, they were deported. Other stories have emerged of people with legal visas getting detained for multiple days or weeks in ICE custody with no clear reason other than someone didn't like which border they were entering at. These stories make it clear that anyone entering the U.S. is taking a kind of risk that has never before been a concern, and that people attending international conferences in the U.S. need to be careful about what they say online and what they say privately on devices they carry into the country. While historically the U.S. has valued freedom of speech and valued working with international partners, the current situation doesn't match past experiences. As someone who has traveled the world to discuss science, I'm deeply saddened by what is happening. Science is a collaborative process, and we can never know what human is going to be born with the correct combination of intelligence, curiosity, and imagination to make tomorrow's great discoveries. I grew up on stories of the Indian Chandrasekhar, the German Einstein, the Italian Fermi, all working in the US to rapidly advance our understanding of nuclear reactions and relativity. For a long time, many of us have wondered how much research has been slowed because the right people were born in either the wrong places or the wrong bodies and lacked the necessary advantages to become research scientists. Now we must also ask, how much research will never be done because the right people never have a chance to meet and brainstorm and collaborate on the research that changes how we see our universe? It's a dark day for science. Up next, I'll be bringing you this week's tales from the launch pad. Stay tuned. It has been a busy week for launches. On March 6th, Arianespace launched the second flight of the Ariane 6 rocket from their French Guiana spaceport. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale.
Board was CSO-3, a French optical spy satellite. The launch was a success, with the rocket's second stage engine successfully relighting twice, first to put the payload in its required orbit, and second to perform a de-orbit burn. It failed to do this on the first flight, which required redesign of the upper stage systems. On March 6, SpaceX launched the 8th flight test of their Starship rocket from the Texas spaceport. Let's watch the explosion.
Where you can see a pretty good view of all 6 Raptors, especially those 3 inner ones, one of which we're going to hopefully relight a little bit later. And we just saw some engines go out. It looks like we are losing attitude control of the ship.
Ship FTS is saved.
So we're still getting video down from the ship. You can see we've lost several engines and we've lost attitude control of the vehicle. So we'll continue to stick with it.
Really not a lot to say about this one. It failed for the exact same reason at nearly the exact same time down to the second as Launch 7. Once again, there were major disruptions to air traffic in the Caribbean. The one positive I can come up with is SpaceX's repeated highly visible f***ups make the people in the Trump administration who want to cancel SLS look less than wise. We'll see if Flight 9 meets the same fate. On March 11th, SpaceX launched the SphereX Punch mission on a Falcon 9 from Vandenberg. Let's watch the launch.
5, 4, 3, 2, 1. Ignition. Liftoff of the Falcon 9. Go SpaceX, go SphereX, go Punch.
SphereX and Punch on their way to map out our universe like never before and revolutionize space weather forecasting.
This mission has had many highly visible problems, with repeated delays attributed to the rocket and SpaceX's integration of the payloads. However, when it finally lifted off, the launch was successful. SphereX will survey the entire sky in near-infrared at significantly higher resolutions than previous infrared all-sky surveys. The goal is to explore the very early universe, specifically the epoch of reionization and the origin of galaxies. Punch is a 4-spacecraft constellation which will study the Sun's corona and heliosphere. The satellites will work together to form a 3D image of the Sun. On March 14th, SpaceX launched the Crew 10 mission to the ISS from Launch Complex 39A. On board were 2 NASA astronauts, Anne McClain and Nicole Ayers, a Japanese astronaut, Takaya Oneshi, and a Russian cosmonaut, Kirill Peshkov. Anne is the commander and became the first openly gay person to command a space mission. Nicole and Kirill are performing their first space missions, and Takayu his second. The launch was scrubbed once because of problems with the launch pad hydraulic system. After spacecraft separation, the camera pointing towards Dragon captured several pieces of foam liberating themselves off the top dome of the Falcon 9 second stage. SpaceX said it wasn't a concern, but they will add the standard closeout blanket common on all non-Dragon missions to the next second stage carrying a Dragon to prevent the debris from shedding. We keep track of orbital launches by launch site, also called spaceport. According to Rocket Launch Live, so far this year, the United States has had 35 launches, China has had 13, New Zealand, Russia each have had 3 launches. French Guiana, India, Japan, Kazakhstan have each had 1 launch. This makes the total number of launches so far this year 58. Of these 58 launches, there have been 3 failures, reminding us that space is hard. And while space is hard, being a planet is also hard. Before we go, I want to bring you a story that looks to rewrite a bit of our world's history. Researchers studying the geology of an Australian feature called the North Pole Dome, despite being located in Western Australia, found evidence that the feature is associated with a 3.5 billion-year-old impact crater. The object that struck was more than 100 kilometers across and hit at more than 36,000 kilometers per hour. This massive impact turned the local minerals into what are called shatter cones, a kind of fractured rock only found where impacts have occurred. This impact is more than 1 billion years older than the next oldest known impact, and tells us that other ancient craters may be present and masquerading as just part of the landscape. This is your friendly reminder that our world has been shaped by many different forces over its 4.5 billion year history, and some of those forces are truly out of this world. And that's it for now. Good night, everyone, and remember to look up. Oh, and please give this video a like and subscribe so you and the world will know when new science is ready to be learned. Thanks.